Hi guys, so today we'll be talking about harmonics and overtone. So what is really harmonics? But before I proceed, welcome to Concept Mastering. Please like my videos, share, comment, and subscribe to get more videos like this. So what is harmonics? Harmonics is a mode of vibrations of systems that produces a specific frequency, that is a pattern of vibration of the strings. Harmonics does the pattern of the vibration of the strings, just showing the pattern with the vibration of the strings. That's what harmonics is. Then overtone. Overtone are frequencies that are higher than the fundamental frequency produced by a vibrating object. Very simple. Overtone are just higher than the fundamental frequency. That's the one point you should just know about it. That's one point you know. So now let's first talk about what is node and antinode. Now, our nodes are formed. They are formed when there is no vibration. Like when it's at a stationary point, when there's no vibration, that is why our node is formed. While your antinode is formed where we have our maximum vibration. We will have our maximum vibration. At this moment, we have movements. Yeah, something like that. So now, let's first talk about our first harmonics. Our first harmonic. So this is it. This first harmonic, we have our node, antinode, and node. This is our first harmonics. This is our first harmonic. So this now. Yeah, this is our first harmonic. Now, how do we get the length of this our first harmonic? Now listen. To get the length of this is from your node to your antinode is actually quarter of your wave lambda. Quarter of your lambda. That means from here to here is lambda all over 4. From here to here is lambda all over 4. So when you plus two of them together, let me write this for you. From node to antinode, either node from antinode or antinode to node is lambda all over 4. The same goes with this. Lambda all over 4. So if you want to get the length of from here to here, this point is actually if you are going to plus lambda all over 4 plus lambda all over 4. So our length will be equals to lambda all over 4 plus lambda all over 4. That should give us for LCM, then 2 lambda, 2 we cancel 4, 2 here, 1, 2 in 4, that is 2. So we're going to have our length is actually lambda all over 2. Lambda all over 2. So that's our first harmonics. That's our first harmonics. So now let's substitute this for our fundamental frequency. You know that our V is actually F times lambda. If you make F your subject of the formula, that's going to give you F is equals to V all over lambda. Exactly. Now substitute. Let's assume we make lambda is subject of the formula here. That will give us lambda be equals to 2L. So now substitute your lambda equals to 2L in this one here. That is going to give you your F will be equals to V, which is your velocity, all over 2L. All over 2L. I can even draw this diagram for you now. I can even show you the way this wave is. Then this antinode, this node, antinode, and node. This is it here. Exactly, this is it here. This is your antinode. This is your node, this is your antinode, and this point again is your node. The point where they meet is your node. The point where there's a maximum vibration there is your antinode. Just note that. So now I'm comparing with this with our normal wave equation here. So your F is equals to V all over 2L. The F is equals to V all over 2L. And your F here, this F here is your fundamental frequency. Your F naught is actually called F naught. Is your fundamental frequency. So this is it exactly. This is it here now. So you have your F is equals to V all over 2L, where your F is your fundamental frequency, and this is actually your first harmonics. Which is actually your first harmonics. So now let's get our second overtone. Our first overtone. This is number 1. Our first overtone, which is our second, which is actually second harmonics. Exactly. Your first overtone is actually your second harmonic. Now, this is how it is now. In that we have our node, our antinode, our node, and our antinode, and node again. Exactly. Now, this is the trick here. This is how I normally note my own now. When I see antinode, you have antinode there, you have antinode there. Now, the number of antinode is always equals to like the number of the harmonic, the number of the harmonics. Now, like I told you, now this is our first overtone, and our first overtone is actually our second harmonics. Now, since this is second, and second is actually 2, that means you are going to have 2 antinode. Since this is your second harmonics, you're going to have 2 antinode, and this is here 1, 2. That's just the trick I normally use to get my own. Once I'm finding my first overtone, and I know that my first overtone is actually my second harmonics, and when I have second harmonics, I always have 2 antinode inside it, so I know what to do. So this, I'll just write my node, my antinode, my node, my antinode, and my node. This does it. The same thing we did in the first one now. To calculate the wavelength of this is actually from node to antinode, or antinode to node, and from node to antinode is actually quarter of your lambda. So from here to here is quarter of lambda, from here to here is quarter of lambda, from here to here is quarter of lambda, from here to here is quarter of lambda. How many do we have? We have from here to here is 1, from here to here is 2, from here to here is 3, from here to here is 4. Exactly. That means your length will be equals to 4 times your lambda all over 4. Can you see? Very, very simple. So 4 will just cancel 4. That means our length is equals to lambda. So now you compare it with your fundamental frequency now. You compare it with your fundamental frequency now. Now you have our frequency here is actually V all over lambda. Therefore, our frequency will be equals to V all over L. That means when you substitute your lambda equals to L in here, you have your V is equals to all over L. Your F is equals to V all over L. Exactly. Now, like I told you before, we compare it, each one we are doing, we always compare it to our fundamental frequency. We compare it to our fundamental frequency. Now, we know that in our fundamental frequency, we have, which is actually your F naught is equals to V all over 2L. V all over 2L. So how do we make it to actually, how do we compare it now? How do we actually compare it now? Since we have our VL is equals to F, therefore you just multiply both sides by 2. Yes, like this one here now, you just multiply both sides by 2 for you to compare it, for you to actually compare it. So that is going to give you your F, which is this one, which is your first overtone, will be equals to your second harmonics. Yeah, second harmonics. Now this is how I did it in now. You have our F, let me just show this. You have F naught here is equals to V all over 2N, right? Now you want to compare this guy with this now. You want to compare this guy to this. Like you want to make this guy equals to this, something like that now. Therefore, you just do you just multiply both sides by 2, yeah, exactly. So when you multiply here by 2 and multiply here by 2, these two will cancel these two. So therefore we now have our E naught is equals to your V all over your length. Now, and as you see here, that we have your V all over length is actually equals to F. So therefore, your V all over is actually equals to F. Your V all over L is actually equals to your first overtone. That means your first overtone is actually equals to your second harmonics. Your second harmonics. No, so you know your second harmonics is actually equals to twice your fundamental frequency. Twice your fundamental frequency. This F naught here means your fundamental frequency. So that's actually how we got our first overtone. Just remember, you just compare this one with this one. You know we have V here all over lambda and V all over length. So I just compare this one. This is how I did it here. You don't multiply both sides by 2. So you cancel 2 here. So you're left with V all over L and 2 F naught. And you know that your V all over L is actually equals to F. So therefore your first overtone will be equals to 2 times your fundamental frequency. Is actually equals to 2 times your fundamental frequency. Now let's just do the third one now, right now. Let's do the third one. Let's find our second overtone. Second overtone, which is actually our third harmonics. Harmonic, yeah, our third harmonic. Now, like I said earlier, this is the trick I use. Since we have our second overtone is actually equals to our third harmonics. Now, that means we are going to have 3 antinodes in it. We are going to have 3 antinodes. Let us write out our 3 antinodes first. 1, 2, 3. Now, this is it here. So therefore, this is node. This is node. This is node. Yeah. This is it here now. Exactly. I'll just first write my node, then balance it with my. I'll first write my antinode, then now balance it with my node. So we have node, antinode, node, antinode, node, antinode, node, node. You have 3 antinodes there. Like I always said, I always use my antinode to always get it. I always use my antinode to always get it. I can even draw this thing for you. So let me try to draw the vibration. It starts from here like this and goes like this. Yeah, I think I'm getting it. Yeah, she's actually like this. See, the first one here is your node, here is your antinode, here is your node, here is your antinode, here is your node, here is your antinode, and here is your node. Very simple. the point where there is no vibration, like the point where it meets together, is actually your node. Then the point where there is a maximum vibration is your antinode. So this does the diagram. Now, how do we got this? The length. How do we get the length of this now? How do we got it? Like I said, your node, from node to antinode, antinode to node, is actually quarter all over your wavelength. It's quarter of your lambda, quarter of your lambda. So let's count to here. From here to here is quarter of lambda. 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 How many do we have? From here to here is 1. Here to here is 2. From here to here is 3. From here to here is 4. And from here to here is 5. That means to get the length of here, actually equals to 5 lambda all over 4. 5 lambda all over 4. And when you make your lambda the subject of the formula, your lambda will be 4 length, 4 times your length all over 5. All over 5. Let's substitute it in our normal wave equation. You know, our F is equals to V all over lambda. So that means our V be equals to, that means our V will be, our F will be equals to V all over 4L all over 5. 4L all over 5. That will be equals to 5V. 5 times your velocity all over 4L. Over 4L. Just hold on, please. Now, if you notice something now, I actually didn't calculate it well now. You can see there's an error here now. There's an error. If you calculate it well, we have, I told you, from our node to our antinode is actually quarter of our lambda. Now, from here to here is 1. From here to here is 2. From here to here is 3. From here to here is 4. From here to here is 5. From here to here is 6. And I wrote 5. Can you see where the mistakes come from? So that is actually wrong. It's not supposed to be 5 lambda all over 4. It should be 6 lambda all over 4. I repeat again. From here to here is 1. From here to here is 2. From here to here is 3. From here to here is 4. From here to here is 5. From here to here is 6. How am I calculating it? From my node to antinode is actually lambda all over 4, and you have it in 6 places. So this actually wrong. The wavelength of this is actually wrong. So what is the actual one here? Our wavelength is actually equals to 6. 6 lambda all over 4. So 2 in here is going to give you 3. 2 in here is going to give you 2. 2 in 4 is going to give you 2. Exactly. This is what we're supposed to get. 2 lambda all over 2. 2 lambda all over 2. This is very, very simple. You can see, from even me, as I'm even doing that, I was able to realize my mistake, and I was able to correct it. Because I just look at it again, and because we are having this in here, it's supposed to be 6. Your second overtone is supposed to be 6. From here to here is 1. From here to here is 2. From here to here is 3. And from here to here is 4. From here to here is 5. And from here to here is actually 6. So that is it. Now we still compare it to our normal frequency. I'll just the way I just did this one here. That means our F is equals to, with V all over lambda. If you make lambda the subject of the formula here, your lambda will be equals to 2L all over 3 here. 2L all over 3. This is what your lambda is going to give you. 2L all over 3. So now we're going to put substitute our 2L all over 3 here in this wave equation. That means our F will be equals to our V all over 2L all over 3. Listen very attentively. This is very, very simple. If you just pay attention, you understand what I'm saying. You get what I'm saying. Now, this is normal mass here. The one where you have something under your denominator, you just go up. You just simple mass there. So your F will be equals to 3V all over 2L. 3V all over 2L. Now, like usual, we are going to compare it to our fundamental frequency. But we know that our fundamental frequency, which is actually F naught, is equals to our V all over 2L. Our V all over 2L. Now, how do we compare this with this? How do we compare this with this? Remember, this is our second over. We're dealing with our second overtone. Now, here's the trick now. You know our second overtone is actually equals to 3 times V all over 2L. This is still the same. This thing here I wrote is still the same here. I just bring out the 3. The 3 here is still multiplying this. You just simple mass. You just simple mass. Now, if you now check here now, you see that our F naught here, our F naught is actually equals to V all over 2L. V all over 2L. So you now put your F naught here. When you see your V all over 2L, you just put your F naught. Just substitute it here. That means your second overtone will be actually equals to 3 F naught. It's very simple. It's very simple. I just say you just compare it. When you just arrive, you just compare it to a fundamental frequency. You have 3V all over 2L. All over 2L. But we want to compare it to our fundamental frequency. It just simple mass. I just separate this. It's still multiplication. You see our multiplication. 3 times V all over 2L. But we know that our V all over 2L is actually F naught. So I just put my F naught here. Therefore, our second overtone is actually equals to 3 times our fundamental frequency. 3 times our fundamental frequency. So that is actually how you got. That's how to get your fundamental frequency, your overtone, and your harmonics. Your harmonics. Let me just give you some brief something here. Your F naught. Just note your F naught is actually V all over 2L, and this F naught here is your first harmonics. Now your first overtone is actually V all over L, and this is actually your second harmonics. Now your second overtone, which is your third harmonic, is actually 3V all over 2L, 3V all over 2L, which we got here. Now your third one, your third harmonics, which is actually your third overtone, which is actually your fourth harmonics, is actually 2V all over L. Then the fourth one, your fourth overtone, is actually 5V all over 2L. Your fourth overtone is your fifth harmonics. So that's actually how we actually got it. Now in the question, they will ask you to find either your first overtone, your fundamental frequency, your third or second or first overtone, or your second or third, your fifth or fourth harmonics. This is the formula you are going to use. If they ask you the fundamental frequency, you use this formula. If they ask you your first overtone or your second harmonics, you use your F equals to V all over L. The same thing, if they ask you your second overtone or your third harmonics, you use F equals to 3V all over 2L. The same goes with this. If they ask you your third overtone is your fourth harmonics, which is actually F equals to 2V all over L. If they ask you to find your fourth overtone. Your fourth overtone is actually your fifth harmonics, which is actually F equals to 5V all over 2L. So it's very, very simple. It's very, very simple. So that's how to find question, and that's the formula you're going to use when they ask you to find any question in overtone or harmonics. Like I said, subscribe on this my YouTube channel and like my videos. I'm going to send them more. I'm going to get more videos on question on harmonics and overtone. I'm going to send more videos. If you don't subscribe, you will not get my video, but if you subscribe, you get my video. So thank you very much for watching. Have a wonderful day. Have a wonderful day.